actually make it a 3 wide. And I'm going to make you 0.3 tall. Now my cube is on the ground, just a little bit elevated, and I made it 0.3 tall because when I navigate, I can walk up steps that are 0.4. So that's important. I can walk up to there. I need to walk up even further. So let's move this back a bit, copy it, paste another one in there. This one I'm going to make bigger, 0.65, 0.325, just to have it at the right spot. And now, when I bake things, a path gets created up those stairs. Yay! This is awesome because now I can navigate any object from down here to the top of the stairs, and it will walk up the stairs like it's supposed to. It'll get to the top of where it goes. If this object was not big enough, it was not going to be walkable. You can actually have things in there. Let's go look back at our objects here. I could make them not walkable and still be navigation static. And it just says, I've got this big object there that makes a hole in the nav mesh that nobody can get on top of. You can't walk on top of this spot. But if you do want to walk on it, you can, and it connects up that path. Now here's something else that can happen. I want to add in some of those off-mesh links. You can do them by hand, like we saw, or we can generate those automatically. Generate off-mesh links. Generate off-mesh links. And I should be able to jump around because I need to change my jump distance. Let's say I'm at 1 at the top of that cube. If I make my jump distance 2, then I get a few. They're not in the right spots where I expected them to be jumping off the edges. Yeah, let's try that as well. Yes, there we go. That's what I was expecting. The drop height says you get to the top of that level, you can jump off of it. It's a single direction from the top to the bottom, so the navigation won't try to jump up. It will drop down from the bottom to from the top to the bottom. And you can put those in manually, or you can say, find them for me. Nav mesh, do it automatically. Okay, so that gets me a nice level. See what happens here. Here's my stuff. I can barely see what's going on because of my angles. But I do have all those pieces in there.
Does that jump distance do anything then if it's just the drop height that's allowing you to jump off that?
I did not remember the difference until I clicked on them and it didn't do what I expected.
Okay.
So I will have to go look into that to see what jump distance will do. I think it relates to objects can be jump as well. You can jump from place to place horizontally instead of dropping from the top down. And I think it controls that because if I turned this,
it's like from rooftop to rooftop.
Yeah, if I turned that cube into something jump, I notice that when I bake things, I am playing. Yes. Okay, so if I turn that cube into jumpable, it turns into red and says things can be jumped from here, I think. And the areas, when you're using some kind of jump link or jump area, it costs you twice as much. That cost idea from what we were talking about with the A-star search can be built into whatever kind of areas we want. Adding sand, adding water, all those different things can get different costs, and you can build them in. Sand takes you a really long time, and I think now back in the object I can pick, I can pick a sand navigation area for a certain object type, and it will change it and change the dynamics of what happens. the navigation paths that get created are based on those. And we saw before we could programmatically change those by saying, hey, navmesh, this object now has a new type, now has a new way of navigating through it. So if a flood comes through, you can add that in. Now there's water here. Change the textures, change the nav mesh area, and the agent should respond appropriately. Okay, so I have my first person controller. Let's move you over here so you can really see what's going on. There's my stairs. Okay, so what else do I need? I need some kind of dog. There's my dog. And this dog is going to be a nav mesh agent. Navigation, nav mesh agent. To really make the nav mesh agent work, we need our own scripts. Saw those before. Let's make a new script. Dog script. Dog script goes onto the sphere. Don't forget to connect them. And now we can open it back up. Give ourselves our pieces. Public game object target. Human. Start. One more thing here, make it easy for ourselves. Nav mesh agent, agent, and just to start, agent, this is what we were doing before, equals target transform dot position. Okay, so obviously we don't have an agent yet. So back at our sphere, we need some kind of target. Create empty game object. Stick it on top there. This is my target. And I will throw that into my script for the target. And while we're here, let's throw the first person controller into my human spot. Okay, so my agent is not moving. Why is my agent not moving around? Destination equals the target transform position. My navigation. Oh, that's a weird. I still have it as sand. Let's make that walkable. Clear things, bake them. Where is my target? There it is, it's up there on the top. If it starts to go, no, it's not moving.
The chat says it's not initialized.
It's not initialized.
You need to, from the start, you need to get component navmesh agent.
Oh, right, I forgot that. Yes, thank you. Thank you very much, CD24. Let's go back. The agent doesn't exist. Yes. Agent equals get component nav mesh agent. Go find it. Hooray. I should have seen that in the console as well. He's moving. Okay, cool. So the dog goes to the target.
Why is it sort of floating?
I think it's floating because the nav mesh agent itself is taller than the object that I put it on.
So you can adjust the size.
Yes, I think I should be able to adjust the size of the nav mesh agent. Its size, its height, etc. can be changed here, and I think that would change where it is. So yeah, my circle is sort of levitating right now because of that. Yes, so thank you. That works. Any questions so far? This is stuff we've sort of already done, review in some ways, quickly getting you up to the speed of where we are. Any questions so far? We've got a nav mesh built. We've got an agent in there. It's moving around, doing stuff. Okay, so I want this dog to be more interesting. I want this dog to go fetch stuff and bring it back to me. It seems to imply that I don't want to just have the steering behavior like we had before, follow this thing around, move it. There has to be some kind of change of state, some kind of change of attitude of the dog. In my mind, this dog has 3 different states right now. It can be going to fetch things, it can be returning back to me, and it can be waiting. 3 different states that the dog could be in. That gives us a picture when I start to conceptualize this. We're waiting, we're fetching, and we're returning. And it sets up these connections of what the dog can do. The dog starts off sitting next to you, waiting for you to throw the ball. You throw the ball, it goes and fetches the ball. When it finds the ball, it returns to you. After it returns to you, it sits there and waits. So there's states involved, and there's transitions. Now, some of you have heard about state machines before. Some of you maybe not, but some kind of similar things happen in robotics. If you've taken a robotics class, this idea might not have been called a state machine, a finite state machine. That's what we're going to call them here in the game AI literature. You hear a lot about state machine programming. It's not the most complicated AI, it's not the most intriguing AI, but it's an effective AI that gets the job done and is relatively easy to sit there and program. So I want to sit here and program this state machine, this finite state machine, not flying spaghetti monster, but finite state machine is what we're programming today. So let's see how we can do that inside our script. Let's add a few more pieces. I'm going to make an enum of my possible states, wait, fetch, and return. Gives me 3 markers that I can say, what state am I in? Gives me really helpful names for them. And the enum property, just as if I said int wait equals 0. You're probably all familiar with enums. They weren't around when I learned how to program, so they're kind of cool and new to me all the time. When I use them, but you're like, okay, enums, they're old hat. So enums can help us. We just start using them now, and we can write whatever we want here. To say what my current state is. Current state equals int states fetch. Switching things up here a bit just to say my agent starts off in the fetch, not the fetch. I want to start off waiting. Yes, that's even better. My agent's going to start off sitting next to me. The dog is waiting for me to throw. Okay, so now in my update function, I can set up a lot of if statements. The way I want to capture these transitions, I want to say, hey, if I'm in the wait state and my transition condition is true, change myself around, do something new, take myself to my new state. That's what we're going to start capturing here. So it's going to have this idea of if current state is equal to states.wait,